See, the students, let us not underestimate the capacity of the students. See, sometimes what we feel, they don't have enough mathematics. No, not at all. Only thing, they lack mechanism. That is what, understand the mechanism, using that what they know. They don't understand. They have got knowledge. They don't know how to use their mechanism and the knowledge and the logic and to do the problems. So this is what we have to do. See, we should, they are unable to just see that direct their through mechanism along proper channels. That is the problem they face. Now, first of all, they must understand the problem. This I have done the problem, but still I am just explaining everything once more. You first understand the problem. That is the first category, that is the criteria that we needed. What is the unknown or what is to be proved? What are the data? What is the condition? Is the condition sometimes sufficient data? Is the condition sufficient to determine the unknown? That is also very important. Sometimes we have to go roundabout method, or you have to take one more step and then you have to go through the another step, and then only you can just prove the or find the determine the unknown. Before the calculating the unknown, you have to just find some other unknown, and through the unknown only you will be able to just find the unknown that has been asked in the question. That is the thing. Then draw a figure. Then introduce suitable notation. That is very important, as we did in theta and all. Separate the various parts of the condition. That is also important. Now there may be too many conditions. Now separate the various parts of the condition. See, the problem may have 2 conditions, 3 conditions or 4 conditions. Now you understand the conditions, and then you should arrange the sequence of the conditions to reach the unknown or to find the unknown. You should not just jumble here and there. Then what happens? You will end up in problems. Then you must be able to understand you have already just reached a block where you have to retrace the paths and then go back and try to get to this spot. Now second, devising a plan. Have you seen it before? This type of problem have you come across before? And or have you seen the problem in a slightly different form also? That's what I am planning to just do one more problem for you. Do you know a related problem? Then do you know a theorem that could be useful? Sometimes we have theorems and all these things, whether that can be implemented here. Look at the unknown and try to think of the familiar problem having the same unknown or similar unknown. There is a problem related to yours solved before. Some problems should have been already just solved before we have taken up this thing, and somebody would have solved similar problem, then you try to do it. This is like a swimming where somebody is swimming and then you try to leg your legs and then read and all these things, and you are following somebody similar to what you are supposed to do. So could you use it? Could you use its results? And possible to use its method. Is it possible to use that method also? Could you restate the problem or analogous problem? That is the thing. See, carrying out the plan. To carry out the plan, you need first patience, no fear and concentration. That is important, because most of the students, when they take up the problem, they already have in their mind that he is not going to just be successful in finding the unknown or getting the result or something like that. That what happens, just flocks his brain, and he is unable to get the ideas also, because that is blocking. So that he should not have any fear and concentration. See, we always tell, to do any mathematical problems you need 2 things. One is the concentration and another is the patience. You examine the details one after another. Every step just you go through it, this is the thing, and patiently one after another till everything is clear. Now it's the 2 teachers, this thing is there, they should allow the student to think. Suppose if he is unable to devise a plan, then guide him one step at one time only. Not all the steps. If you just think, he will not be able to think and get the ideas. Then guide him one step, let him think, then the next step. So go step by step, kindle the fire. That is what we are supposed to do. This is what I have given the synopsis of what you are supposed to do in the class and how you are going to guide them. See, I am taking another problem which is also of similar type of what you have done the last one. Now this is also something connected with the hypotenuse and right angle triangle. Now see the thing, the sum of the lengths of the hypotenuse and a side, only one side, and a side of the right angle triangle is given. It is given. When the area of the triangle is maximum, see, that is the thing. What is the area? When the area of the triangle is maximum, what are the angles between the sides? Now the right angle triangle, so one angle is known, that is 90 degrees. Now we have to calculate the other two angles. Even the other two angles, if one angle is known, the other angle will be 90 minus theta. This is what. Now what is the unknown or find, as I just gave you the glimpses of how to solve the problems or how to attack the problems, how to solve it. Now what you understood? The one thing is, given that, see, the unknown is the angles between the sides. Then what is the data given? The data given is a right angular triangle, and the length of the hypotenuse and a side is given. That means what is that? It's not given. The student will ask you, sir, it is not given, what you are telling it is given. That means you can just take them, the sum, as some constant which is not a variable. So that is how the E is given stands for the sum of the length of the hypotenuse and a side is a constant. So these are the things you have to just explain and tell them. And the area of the triangle is maximum. That is the thing. See what happens. You have to find the angles when the area of the triangle is maximum. Now what happens? See, you need a triangle. So you just draw the diagram of the triangle. So this is hypotenuse, this is your A, B, C, this is your hypotenuse, this is your A, and this you take it as Y. Now either you can take this angle or this angle, it makes no difference. They may ask you, sir, why you are taking this angle as theta and what about this? Then you have to tell them this is 90 minus theta. See, the given the length of the hypotenuse and this side. You have to explain to the students and ask them. When it is given, means that is a constant. So when it is constant, what happens? When you differentiate, it becomes theta. So your area varies with respect to theta. See, it's given. That means the student may ask you, see, sir, how it is given, then what you are going to do? The H and A, they are not just given at all, you are taking it. Then you should tell them, since H and A are given, means if I add H plus, that is H and A, that is your H plus A, that I can take as a constant K. And not only that, now sir, you have introduced theta, then this theta, H and K, when you add them, it is going to be constant. How the area is going to become maximum? It depends again, as I told you, according to this is theta. H plus A, because, see, you may ask me, sir, when H plus, you should explain these things to the students. Now H plus, see, 12 plus 2 is, this is your 14. Is it not 6 plus 8 also 14? So they may change, A and H may change. Suppose the sum is equal to some 14. What happens? This may be 12, that may be 2, and this may be 6, that may be 8. In so many ways, the addition will be a constant, and these will change. When they change, what happens? Your theta changes. But H plus A doesn't change. So that is going to be constant. Now what is given? The area is now the area is going to be maximum depending on the value of this theta. But see, the previous problem and this problem, we are not going to use this theta at all. That is the thing here. So you are off into base into height, that is your A into Y, isn't it? Now your y, because you can't have too many variables also, because h and a are involved, we can just add them and all. Now what happens here? This is your half into, this is a right angle triangle, so your y is equal to root of h squared minus a squared. Now what happens again? See here, 2 h and a, as I told you, now see that thing. The addition gives you a constant, but the a and b takes, a and h take different values, see. So it may be 12, see, so many ways, 3 plus 9, that is your, 3 plus 11, that is your 14, like that it goes, is it not? So the addition is going to be constant, but a and h are variable, that is the most important thing, depending on theta. So I am just eliminated y and I brought h squared. Now what happens again, a and h are variable, I cannot have two variables here. So what I do, a by 2 into root of, your h is equal to, is it not k minus a whole squared? K minus a whole squared minus a squared, that will give you a by 2 into k squared minus 2ak plus a squared minus a squared, that gives you a by 2 into root of k squared minus 2ak. This is your a. Now as I told you, the area varies, because again as I have to tell you, the area varies according to a and depending on a and y. Now the sum of this thing also become this thing here. So I have to differentiate this or I am going to differentiate a with this area with respect to this a. Now let us see what happens. See, instead of use, because there is a square root, I don't want any square root and all these things, I want to make it simple. It is allowed that you can square it also. So what happens, your a squared equal to some a squared by 4 into k squared minus 2ak. So I can call it as u, a squared by 4 into k squared minus 2ak, that is your, now this is your k squared a squared by 4 minus 2a cubed k by 4. Now I differentiate with respect to a. Now I differentiate with respect to a. So your du by dA, that becomes k squared and 2a by 4, that is your a squared, and this is equal to minus 2 into 3 into a squared k by 4. So this is going to give you 2a k squared, or I can say, I can simplify this thing also. This is k squared a by 2 minus 3 a squared by 2 k. So you get what happens, equal to 0. As I told you, this is, I explained the last problem, we take is the differentiation du by dA equal to 0. So your k squared a by 2 equal to 3a squared k by 2, that is equal to what happens, your k equal to 3a, isn't it? So a equal to k by 3. Now your a is known. Now he is asking you to find the angle. Now I am going to do it this thing. This is, I don't know. Now a is known, k by 3, and I can get the value of h also, isn't it? Because already you have taken h plus a equal to k given. That is both hypotenuse and the one side added together, that is given. So your h is equal to k minus a, that is equal to k minus k by 3, that is 2k by 3. So your h is known. Now you can do it in any way, that is, see, we have to calculate the value of theta. That is easy because two sides are known. Or if you are very keen on going to further finding the value of this thing also, you can. Now a is known in terms of k, and h is known in terms of k. So I take cos theta, which is equal to AB by BC, that is equal to AB, your nothing but your A is equal to, you already calculated, k by 3, and this is your 2k by 3, this is your 1 by 2. So your cos theta is equal to half, therefore theta is equal to pi by 3, isn't it? So one angle is, you have calculated one angle, therefore if this is pi by 3, this is 90 minus pi by 3, that means that becomes 30. That is so. See, you may be wondering why I have taken two problems and trying to explain this thing. See here, in the last problem, just we introduced theta and then we got the, we just in the minimum, we just calculated the minimum value, and if that is given as minimum value, then we calculated. Here it is the triangle area is maximum, we have calculated the angles. So that is a familiar problems. You can correlate the results, you can correlate the similarities, you can correlate the problems, and we can go ahead and you can just form ideas about these things. That is what I have been trying to explain this thing. So dear students, just these are the things you have to just to inform the students and teach them and make them aware of that mathematics can be done in the most simplest manner if you follow these methods and all. That is, you first understand the problem, then what is unknown, what are the datas, and then the datas, too many information have been given, just try to arrange them in order and in a sequence, go step by step, and then get the values, and then again you can see just whether you have just done the steps correctly. That is what you should do. Good luck, goodbye, thank you very much.